The iPhone 15 Pro and 15 Pro Max are the first phones to shoot professional video in Apple Log 10-bit ProRes files. But are those cameras ready for professional primetime? We tested dynamic range, rolling shutter, and latitude in our lab test.
CineD, your digital cinema tech resource, supported by B&H and CVP.
Welcome to our lab test studio here with Gunther. Today we talk about our lab test of a camera. It's not your typical professional camera though. We're talking about the iPhone 15 Pro and iPhone 15 Pro Max cameras. Now, why do we think a phone is a professional camera and worth testing in our lab?
Yeah, that's an interesting question. And so far, we have never considered a phone to be tested in the lab. But two things have changed. For one, Apple is now providing a real log mode with a proper white paper describing the transfer functions. And secondly, it also has professional codecs like ProRes. And you can tap into that also via an external storage device via USB-C.
I mean, the internet is buzzing with footage from the new iPhone. I mean, this is really a first. There is no other manufacturer that we know of that actually provides a log profile on a smartphone yet. Now, log, of course, everybody thinks about, we have log, we talk about more dynamic range, but that's not really the main thing, right? Or the only thing.
Yeah, I think a very important feature of log is that it is not using the typical image processing things or automatic image processing things that are happening in a phone, like automatic tone mapping, for instance, that would brighten darker areas of the image or tone down brighter parts of the image
in the same
scene. Yeah. In order to give you a good contrast for the scene. With log, you get a lot of consistency. So basically, the exposure is fixed. And secondly, also the sharpening that was happening in past phones.
Well, in any phone. If you look at the standard video mode in iPhones and compare it to something, a graded scene from the Apple Log, you will immediately see the difference that it, like the original normal video mode, looks very over sharpened, right? Because it's intended to be used as it is. You just shoot something on the phone. And there is usually no post-processing done, of course. Something that's shot on a phone.
Of course.
But yeah, so basically we go as close as possible to what the sensor gives us in theory. And be able to post-process it.
Yes.
Dynamic range is a different story, I guess. I mean, it is...
of course, with a log profile, the way it is set up, it is intended to capture the full range from the brightest areas of the image down to the darkest areas, but in a consistent and predictable manner. And that's a very good basis for our dynamic range testing, because that's also what we do with all the other professional or hybrid consumer cameras. That's what we do in the lab. However, we also had to tackle with one problem, or actually two problems. The one is that we always try to be consistent with the lenses that we use. We always use the Zeiss CP, like 50mm or 85mm lenses.
Compact primes.
Yeah. Compact primes, because that gives us a certain distance from the DSC Xyla chart that we are going to describe in a second. You see it in the background here. And secondly, also, of course, we dial in all the parameters in a manual way, like ISO, white balance, the iris, shutter value, and so on. So that was a second thing we had to cope for. And the second part, I think, can easily be catered for by the new Blackmagic camera app, which gives you all the manual controls. But of course, the first part, not, because there are only certain focal lengths available on the iPhone. 13mm, 24mm, 77 on the Pro, and on the Max, you have the 120mm lens.
Yeah, so we had to adjust for that. There's no other way. We don't want to put a additional lens on it. We have to use the native lens. Now, our contacts told us that we should focus specifically on the 24mm lens because that is optimized for performance. And also, interestingly, the front-facing camera as well.
Yes.
We heard. But the 24 was our main focus of the test.
Yeah. So basically, we tested the rolling shutter that we always do for all the 4 cameras that the phone has, like the 3 back-facing and the 1 front-facing. We also tested the Xyla chart and the post-processing or the mathematical processing in the ImaTest, image analytics software. We did not test the 13mm though, because the 13mm lens is a very wide-angle lens and it would cause internal reflections of the chart and thus skew the results. But you get, for all the other different lengths, you get also the ImaTest results and the rolling shutter. We are going to look at it afterwards. We used for the Latitude test, this is our real-world standard CineD studio scene. For this, we used the 24mm and the front-facing one.
So, but let's talk about the Blackmagic camera app. Now, there's a lot of questions online where people are questioning whether the Blackmagic camera app actually taps into everything the phone provides, because
it could be sitting on top of something.
Could be sitting on something. It could be reverse engineered something.
Correct.
And there were some questions when we did some initial testing before this lab test. We also had some questions because we thought we got slightly different results with Apple Log in the normal camera app and the Blackmagic camera app. And the reason for that is simply we found out because you cannot set the white balance properly, you cannot set the ISO. So it's very, very hard to reproduce. But we got confirmation from our contacts that the Blackmagic camera app really taps into the API that Apple provides for log, for the whole log and ProRes workflow, which means it can only deal with what it gets. So it is properly dealing with it.
Yes, it's properly dealing with it. And we got confirmation that it really taps into the hardware image pipeline.
And there is a hardware. And there is a hardware image pipeline for Apple Log.
Yes.
Because that's the next thing. A lot of people are in 10-bit. Because a lot of people are like, oh, actually Apple could have done this, could have put this in any other phone. They could have brought this into older phones by a software update. The answer is no, because it wouldn't be 10-bit. And for this, it really bypasses, like when you switch, it looks simple in the camera app because you just press the ProRes log button inside the camera app once you have it enabled in settings. But it's not simple. It's actually switching the image pipeline and it's bypassing all the processing and giving you that 10-bit that usually you wouldn't have. And that's simply not there, and it is hardware related. So just to put those things out of the way, we have confirmation for that. We can't say more. Good. Let's talk about the next steps. So basically, before we really dive into the test, maybe you can explain a little bit how our lab test in general works for people who haven't actually read about it yet.
There's always 3 things that we try to test. The one is, of course, the rolling shutter. This we do with a strobe light that runs at 300 hertz, so 300 times per second. And due to the readout nature of CMOS sensors going from top to bottom, during that time the strobe flashes, and so you get the sequence of black when the strobe is off and white bars when the strobe is on. And then you can very easily count the bars over the image height and thus calculate the rolling shutter. We did this on all 4 cameras and got some very nice results, which we're going to show in a second. Then the second thing is we use a Xyla 21 chart. You can see it in the back one here. It provides 21 stops of dynamic range, like from the brightest to the darkest part. And when you shoot the chart and process the image afterwards, you see a waveform, how we call it. So it's a very nice representation of the stops a camera can capture, from the clipped patch to the left to the dark stops on the right. And this is the first visual indication of the dynamic range, because you can see, if you go towards the lower stops, you can see what we call the noise floor. This is basically where no more image information is captured in the dark stops from the camera, and the whole curve basically converges into that dark stops. The noise floor is actually very interesting to look at, because you can tell how noisy a sensor by default is, and if there's a lot of internal noise processing going on. This is something we frequently see when we test professional cinema cameras, that in RAW mode, which is supposed to be the least processed, you see quite a pattern in the noise floor where you get a rather noisy line here, which is really spread across a couple of code values. On the phone, we're going to show this to you in a second, you can see this is almost a straight line without any deviation from that straight line. And that hints at a lot of internal noise processing. So what do you do when you do noise processing? Let's assume you have a noise floor like this. There could be hidden stops still in that noise floor. If you noise process it, you basically dig out those stops. And that's, I think, what's going on. So I'm already giving you some of the results. That's what's going on with the iPhone. A lot of noise processing going on, which also means that there's very little code value difference between these lower stops.
But let's, before we dive into this, explain the last part of our lab test, which is the Latitude test and why we do that.
Yes, that's the third part, the Latitude test. So shooting a Xyla chart or shooting or post-processing the image in ImaTest is one part of the story. We also want to provide a real-world scene because that is the most telling, because what do you typically do when you do shooting? For instance, at one point you do underexposure, or you want to preserve some highlights, and then you have to raise the shadows in post. So the question is, how much of the image is still preserved in the shadows, or is it already completely corrupted by noise or some other fancy things that are going on?
So it is really a real-world test of the application of dynamic range, because in reality, you would under or overexpose intentionally or unintentionally something which happens all the time. You change a shooting scene, you don't adjust your aperture or ND or whatever.
Correct.
So you're a little bit underexposed sometimes, or a little bit overexposed. So that dynamic range, more dynamic range, will give you more flexibility in post-production to salvage that footage. Absolutely. Which ironically always means in the past is like the higher end the camera, the more bits it has, like bit depth, right? If you have a 16-bit RAW from an Alexa camera, you can basically under or overexpose, I think it was 3 or 5 stops. Still salvage it in a way.
Yes.
Which is the irony of this, is like that you have a more expensive camera, you can be sloppier with exposure.
Yes. Yes, that's true. That's true. And so this is a real world test. However, it is in a controlled studio environment. This is very important. So we have a standard CineD studio scene where we basically have the lighting and the distance of the subject to the background with the shadows. We cover a nice exposure range with that scene. So when we over or underexpose and then later bring up the image again in post to our base exposure level, that really provides for a very good comparison between the different cameras. And one interesting thing is that if we see, for instance, 12 solid stops in the waveform, and maybe ImaTest is also analyzing close to 12 stops, typically we get about 8 stops of exposure latitude in our standard CineD studio scene. Cameras that are doing a lot of post-processing, a lot of noise reduction in the image, in the latitude test, all of a sudden you see much less of that exposure latitude. So the exposure latitude test is really revealing how much of that exposure or of that dynamic range that you see in the waveform is really usable in a real world scene.
But let's go through the results one by one. Let's start with rolling shutter. So rolling shutter, of course, something that is a constant pain if you have a lot of it, because it means, especially in something small, like a phone, which you usually do not put on a tripod, you hold it in your hand when you're filming, which means if there was a lot of rolling shutter, it would be a huge problem, because you get those jittery artifacts, stuff that we had a lot in the beginning of the DSLR revolution, where those cameras are really not made for filming. You had all those wobble artifacts, and if you pan it really fast, the image, like tilts. So those are the things that are showing a really bad result for rolling shutter. But how did the iPhone 15 Pro fare with this?
Now when we get the question, how does the phone fare, we always have to talk about the 4 individual cameras. And the funny thing is the 3 backward-facing cameras are all around 5 milliseconds of rolling shutter. Here's an example of the 24mm lens showing the rolling shutter result, and also you can see the sequence of black and white bars there, around 5 milliseconds. And all the other cameras are the same. So the 13, the 24, the 77, and the 120mm. However, there is the front-facing camera, and this one shows surprisingly 9.3 milliseconds. Less is better, and we have to say 5 milliseconds is a superb result for filmmaking. We have only seen one professional camera that was able to top that. That was the Sony Venice 2. All other professional cinema cameras, even the Aris, have more than 5 milliseconds of rolling shutter. So with the backward-facing cameras, great. Fantastic.
But we have to say, I mean, this is also probably down to the size of the sensor, because a very large sensor, like a full-frame sensor, will take a longer time to read through. So actually, even if the amount of time it would take from the first pixel to the last pixel, do this line by line, of course, takes a lot longer, even if it was the same speed as on the small smartphone sensor. So of course, it's easier for a small sensor to get an amazing result with that.
Yeah, I'm not quite sure why that is, actually, to be honest. Maybe one of our readers has a good explanation for that. But it is the case that smaller the sensor, the lower rolling shutter values we get.
Okay.
Even though they have the same resolution and you have to go through the same number of lines. But if we get some enlightenment on that,
well, I guess maybe because the pixels are smaller. I don't know.
Yeah, I don't know what it is.
Next result.
So very good results on the rolling shutter front. Next result, IMA test, dynamic range using the Xyla 21 chart. And here you see already the first waveform of the 24mm camera. We can identify about 11 stops above the noise floor. But speaking of which, you can see the noise floor basically consists of a line, and you cannot really identify some noise there. So I have a strong suspicion that this 11th stop is already like pushed out of the noise floor by an excessive noise reduction.
So it's not, I mean, some people on the internet were like, oh my God, the results, the dynamic range is as good as on a entry level or whatever mid-range professional camera. It's probably not, because there is every noise reduction happening.
But it confirms also the thing that we saw, and that's a general comment on the iPhone camera. The lowest ISO that you can pick for each of the cameras, and also in the Blackmagic app you see it, the lowest ISO always changes depending on the camera you pick. This is always the cleanest one, so which has the cleanest shadows. When you raise the ISO, and that's very important, you do not change the clipping point or anything. It stays the same. It's just that all the code values are pushed to higher values. And thus the image gets brighter at higher ISOs, but there's not more light or something entering the sensor, obviously. So it's just like an amplification. However, the good thing that we have to test when we look at the Latitude results later is if you raise the ISO, also the lower stops are getting more differentiated, darker stops. And there's a potential there that you get a better image if you run the iPhone at the higher ISOs. And that's what we did. Also in the dynamic range results, you can see now one example of the 24mm camera at ISO 1200.
One thing we should mention is the current version of Blackmagic camera, when we tested, was 1.1, which still had a wheel to adjust for the ISO value, which literally let you change the increments in 1 point. So it would be really hard to actually hit 1200 ISO because it's like a wheel. So you end up with 1208 or something.
Yes.
That made it really hard. Now, there was an update since we did the test. We just checked there was an update, and now they give you proper steps. So it's like, I think 1250 ISO, and you cannot actually set the app anymore for anything in between. Having said that, we do not know the exact native ISO of the phone, but we know that the lower ISOs, the lowest ISOs actually will give the best results with these cameras. Is that correct?
In terms of cleanliness of the shadows, yes. In terms of if you have to pull up darker parts of the image, no, because of that feature of the phone, that higher ISOs means extended code values, and then the differentiation between the darker stops becomes better. But it also means that you have to apply then some post-noise reduction to really utilize that. We will see that when we look at the exposure Latitude results.
Okay, but then we will, in the Latitude test, we end up at something like a 1200 ISO, right?
Something like that.
For the best raised shadows. Okay, good.
Fine. And you see a table now with the IMA test, dynamic range results at signal to noise ratio of 1 and 2. We have not talked about the signal to noise ratios yet of IMA test. I just mentioned IMA test is basically an image analysis software that would calculate for each of the patches, each of the stops you see in the Xyla 21 chart. It would calculate the signal value of that stop and compare it to the noise. So we talk about a signal to noise ratio. And of course, at the bright stops, you have very high signal to noise ratios. If you approach the noise floor, you're approaching values of signal to noise ratio of 2, for instance, or signal to noise ratios of 1. 1 means that the signal value is already within the noise floor. Now there's one issue if we look at IMATEST results, and this is also why some of the reviewers were hyping about the new iPhone dynamic range values, is IMATEST cannot take into account how much noise reduction is used internally. Now, if we talk about a signal to noise ratio, then in the denominator you have the noise. So the lower the noise is due to the noise reduction, the higher or the more stops you get. Meaning the signal to noise ratio of 2 gives you a higher stop value.
So basically you apply more noise reduction in the camera and the result will get better.
Yes.
But it
could theoretically go to infinity.
Okay, and of course it doesn't mean that the sensor is the best one in the world, it's just that you have the best noise reduction.
Yes, yes. And this is what's happening also in the iPhone footage here. I mean, if you look at specific areas of the IMATEST result, for instance, at the lower diagram, you can see very, very low noise values. And this means that IMATEST also shows the same signal to noise ratio for 0.5, for 1 and for 2. You can see this in the upper right hand side. And this is a clear sign that IMATEST could not differentiate those lower stops in terms of noise or signal to noise ratio. So unfortunately, I think we should not put too much emphasis on these values. Otherwise, you could be tricked into believing at higher ISO values. We have some results here also where we get 13.4 stops at a signal to noise ratio of 2. That's almost close to an Arri Alexa. And how can an iPhone with a tiny sensor be close to an Arri Alexa? This is hard to believe.
Well, Apple is putting a lot of magic into this, but they cannot change physics. So, which is why we have the Latitude test, which is more revealing. Like we said in the beginning, it's actually more, it's a standard studio scene, but it's a more real world representation of how you would expose, over and underexpose, and then pull back or push down.
Yes, and how usable is the image once you pull it back?
Yeah.
Now, how corrupted is it or not?
So how were those results?
So in our Latitude test, what we do is we always try to expose the forehead of our subject, in this case it's my colleague Johnny, such that it's at the cusp of clipping. So we look at an RGB waveform, we look at the red channel, and the red channel is close to clipping on the forehead of our subject. So this is now the brightest part of the image, and from there we start to underexpose in 1 stop increments. Normally we do this by closing down the iris. On the phone you cannot do this, so
it's a fixed iris.
It's a fixed iris, so we are increasing the shutter speed from 1/30th of a second to 1/60th of a second, 1/120, and so on. And then we normalize the image to a base exposure level. And the base exposure level is what you typically would use also when you expose like a subject, a face. It's 60% luma value in the waveform. That's our standard base exposure. And that helps to give our readers then a reference how far you can overexpose over this base exposure, underexpose, and then bring back the exposures back to base exposure level. And this is obviously done in post in DaVinci Resolve. We use the version 18.6, and we use this comparing the waveforms of the over and underexposed shots and matching them with the lift gamma gain wheels in DaVinci Resolve to the base exposure level. That means you will see now the broad back shots. So let's have a look at them for the 24mm camera at ISO 55. And in these shots, you can see that there's very little fluctuations only in the exposure. They all look the same, but once we go into the underexposure and bringing back the image, you can see that a lot of noise starts to kick in, especially at the underexposure value of 2. So when you are 2 stops underexposed, below the base exposure scene, and bring it back, noise starts already to kick in. And that's rather early, because usually we find with proper consumer hybrid cameras that this only starts at 3 to 4 stops of underexposure. Of course, a Red Raptor or an Arri Alexa Mini LF or even an Alexa 35, you can go much, much, much farther down before noise really starts to kick in. But let's stick with the 2 stops under image at ISO 55 for the 24mm camera. Maybe we can apply still a little bit of noise reduction, although by default there is already quite a lot of noise reduction. You can see 2 stops under is still fine, meaning we are already at 5 stops of underexposure. Now let's try to push it 1 stop more to 3 stops under. In the default image, you can see already in the broadback image that it's very, very noisy. Also, you can see a lot of chroma noise and almost like bending. And if we bring it back and still apply noise reduction, this chroma noise doesn't go away. You can also see some sort of concentric circles in the image. This could hint at a potential in-camera vignetting compensation. So obviously there's still some sort of image manipulation going on, but I don't know. Nevertheless, you see this bending, and that's a clear sign that the lower, darker stops are already too close together. And when you expand them, you see the bending. So game over, meaning 5 stops of exposure latitude for the 24mm camera at ISO 55. So how does that compare to recent consumer cameras like the Lumix GH6, for instance? Such a camera is using a micro four thirds sensor, and it is capable of displaying 7 stops of exposure latitude in our standard test. So 2 stops more than the iPhone. If we move up in the sensor size to APS-C, sensors like the recent camera we tested, the Sony a6700, this one shows 8 stops of exposure latitude, and a camera like the Fuji X-H2S, also APS-C, already gives you some wiggle room towards 9 stops of exposure latitude. Full frame, 8 stop, and then moving to full frame cameras like the Arri Alexa Mini LF. This one has 10 stops of exposure latitude, so 5 stops more dynamic range. You can see, say, basically doubling the latitude that you have available. And the leader of the pack is the Arri 35 that we tested last year.
35, yeah. Mm-hmm.
Yeah, the Arri Alexa 35, also APS-C, that has 12 stops of exposure latitude, just to give you the reference. But maybe let's come back to what we said initially. If you use higher ISOs, then you expand the shadow stops, and maybe there's a little bit of less chance of bending. And that's what we see, because if we directly move to the 2 stops under exposed image using noise reduction, it still looks fine, as you can see here. And now let's push it to 3 stops under. That would mean 6 stops of exposure latitude. You can see it looks better than the original one at ISO 55. However, I still would not consider that usable. So for the 24mm camera, that's what it is. Now let's have a look at the front-facing camera, because the front-facing camera showed a different behavior also at the rolling shutter. Remember, it was 9.3 milliseconds versus 5. And what we see here is again the series of underexposed shots. So you can see how we subsequently and successively change the exposure by 1 stop. Now let's bring it up and have a look from 3 stops over to again 3 stops under. You can see the front-facing camera has a much more organic sort of noise processing. It has a much more luma noise and a little bit less of the chroma noise or the blotchy chroma noise that we were able to see on the 24mm camera. But again, if we push it to 3 stops under at the native ISO that we could not use, the native ISO on this one would be ISO 20, but then with our studio lights, we were not able to clip the forehead of our subject. That's why we also used ISO 55 for the front-facing camera. Still, it's the same result.
It's interesting. I mean, that
looks different, but it's still only 5 stops of exposure.
Some people might ask, why did we even test the front-facing camera? I mean, nobody's using this to film anything except for themselves when they're setting up a phone call. But the reality is, I mean, first of all, our context told us, look at it. It's, you know, it's better than you would think.
Yeah.
And also, if you think about it, I mean, of course, a lot of people do video calls all the time. You might do this outside. It actually has to deal with a lot of contrast.
Yes.
Because if you're walking with your phone or the sun is behind you, it needs to do a pretty good job at exposing yourself and then still showing some of the background. And also there is, of course, the chance to use both the front and back-facing camera, one of the front and one of the back-facing and the front-facing camera at the same time, with some apps. So for some creators, vloggers, it might be interesting to do that, right? Film themselves while they show something.
Yeah.
Which is why they probably also put in the log mode into that camera. But why would you would need ProRes log in that camera? I guess that's why.
Yeah. No, but very interesting. And you can see from the nature of the noise and everything, it's a different camera than the other 3 backwards facing ones. Personally, actually, it looks rather organic with the Lumo noise, rather fine noise, but still you cannot push it much farther than 5 stops. So that's it. 5 stops of exposure latitude. And after all, it confirms also Apple cannot do magic to the image. It's still a tiny sensor. However,
with the log, because it's basically it's a catch-22. And on one hand, we all want the least processed image. On the other hand, the less processed it is, the closer it is to what the hardware delivers.
Yes.
And on the other hand, if you look at those computational cinematography and photography tools that are enhancing every year, it's amazing what's possible. I mean, something like cinematic mode, which fakes a depth of field, which you can actually change in post. So you literally film something, or you take a photo in portrait mode or not portrait mode, and it will tell you, well, you can actually change the f-stop afterwards because it recognizes the face. It's amazing. And now you can do this also in post with a video. So you literally film something with cinematic mode. You can say, well, I want, F2 look on this. So everything is out of focus. And then you import this into Final Cut Pro and you can change the focus point to a degree, of course, because if you are in macro mode of the real macro mode of a lens, it really will be out of focus and then you cannot change it. But if it's just, like a wide scene, for example, you can fake this in post. And these modes just become better and better and better every year. And the question is, if you look at how much R&D money do all the big camera manufacturers put into their sensors every year, and not just the sensors, the whole cameras, including their computational cinematography and photography, versus what do Apple and some other smartphone manufacturers do every year? How much money are they able to pull into the R&D of that? And if we're honest, I mean, one of the main reasons to upgrade your phone is the camera. Right? I mean, for me, definitely. It's like 3-year-old iPhone is fast enough for everything I do on a phone. I'm not an iPhone gamer, and I think most people are probably looking at the camera. And it's the camera you always have with you. And I don't know who said it, but the best camera is the one you have with you, and the one you have with you all the time is the phone. So of course it makes sense to upgrade that. It's of course they have to deal with a smaller sensor, but as time progresses, we will see so much, and it's already at a crazy point. But at some point, I expect it will be indistinguishable. The fake depth of field will be indistinguishable from real depth of field. And just imagine having a phone that can give you, like you put a picture profile for a look, you can have a lens profile. I want this to look like a Cook anamorphic. And it's just putting that on top of a normal video, and it looks real. Like how there will be differences to the real thing, but those differences will become less and less and less. And the average consumer at some point will not see the difference anymore. That's my take on that. So what we look in our lab test at is as close as possible to what the hardware delivers us, because that really defines the quality of a sensor. But on the other hand, in real life, this is not everything that matters.
No. If you have a rather well-lit scene, the beauty about log is the consistency. You have a lit scene, and in log, everything is preserved, and there's no auto adjustment of shadows or brightness going on, and that's the beauty of it.
And
the beauty of it, and it just can get better, like you say. Computational imaging will just get better.
I just imagine some of those computational things, if some of the stuff that the phone can do would be possible in a large sensor camera. That would be absolutely amazing. And that's the one frustrating thing I can say about a lot of the traditional camera manufacturers, is that their software isn't always great. It's getting better. but it's still, I mean, I don't even want to talk about menu designs and stuff like that. But if a camera could be as intuitive to control as a phone and have some of those functions, that would be a winner. But let's see.
So let's hope for an Apple full frame camera, or
yeah, either that or maybe they license it. I don't know. But of course.
True, very true.
Yeah, but as I said, I think in a few years this discussion will be different, and we already see that the phones they literally killed the entry camera market, right? I mean, there is no compact cameras with fixed lenses.
Yes.
It's just not there anymore. You look at this was such a huge market. It's just not there anymore.
It's just vanished.
It's out of convenience. People use their phone. In the beginning, it was convenience when the quality was still bad 10 years ago, and now the quality is at a standard where you look at any of those additional, like older compact cameras, and it looks much worse than any phone. So it's just going up. It's interesting where everything progresses. But thank you, Gunther.
Thanks, Nino, for having me.
Thanks for taking the time again to do this lab test. I think it's a very interesting step into the future. And of course, if there are new phones that have log modes, we will probably look at them again and have this discussion again.
Yeah. Sure.
Thanks everybody for watching. Stay tuned to CineD for more lab test videos. Check out the other ones we did on the Alexa 35, and it was the Red V Raptor, I think.
Correct.
And a lot of lab tests. We have dozens of lab tests on our website, and all the results in our camera databases where you can actually compare those results. But do also read the lab test articles that go with it, because of course dynamic range is not dynamic range, like we just learned. And stay tuned. Thanks for watching.